close the box, before we close the box. The neck. Before we close the box. The top. The sides. Bracing. Velcate bracing. Velcate bracing. Velcate bracing. Velcate bracing. Velcate bracing. The shape and the carbon fibre for the stiffness. It just seems to work. It just seems to work. Curved soundboards, which will go like this. The insides of my sides are always shiny with sparkles because when I do the Velcate bracing, there's always a bit of epoxy left over and I use it on the insides. Sides, insides, sparkles, sides are thick, 5-ply, very solid. Very solid. Idea is to have the sound waves reflect back into the soundboards. At the front are the sound holes. Bottom line is you have to move the air or you won't hear it. What moves the air? Soundboards. And the Helmholtz. The helm, whatever it's called, container, which will pump the air out the sound holes like it does in an ordinary guitar. I have square here and square there because this is a stick-through guitar. It goes like this. In this one, out that one, there it is. And then ultimately the strings attached here will keep the whole thing together. Stick through. Banjos use it frequently, not always. It avoids the problem of your stupid neck joint always going wrong. Keeps luthiers employed and allows for adjustment by lower action, higher action, lower action, higher action, lower action, higher action. Can we see it? Shims at the bottom. I use a violin style bridge, thin, lots of holes. You want it to vibrate. There's a whole lot of physics behind that as well. Sometime later, we have a guitar. Sometime later, here it is in its final incarnation. Nice fat fretboard so I can pick properly. It's got This is the second pickup, a fatter, beefier one. Not the original bridge, and no floating tailpiece. The other one broke. And it's travelled, it's gone to Tasmania, and it has been played at parties. It is now plugged in